Hi, so in this video we're going to show how our TCP calibration station will drastically um, optimize your process of changing different tips or dealing with the variability that may come from using the same tip as you screw it into the dispenser. So what do we have here? If I go here to the program, right, I've just written a simple program here that will, we have a well-calibrated TCP and we have a plane and we've set up a toolpath to follow along the lines there of the toolpath. But what we want to do is, we want to make sure that that toolpath stays consistent as we change different tips. Because we may be trying to figure out, like study-wise, we may be trying to figure out what tip we want to use. So over here is our TCP calibration station. It consists of a sensor and a mirror, and all that is needed to set up this TCP calibration are three things. You need to have a well-calibrated TCP. So if we go to the installation and TCP, we have our dispenser TCP is well-calibrated, and we've done that through our 4-point method. We also need to have a cal plane that will be defined as X, as the origin X plus and Y plus, right? And we also will have an IO that we've called cal sensor that will be triggered every time this light path is interrupted. So you can see as I interrupt the light path. And so once we've done that, we are now able to go in here into our installation node and into our UR cap called TCP cal, and we will select these three things. We will select our cal plane. We've just defined that. We will select the TCP that we want to use for our calibration. It's going to be called dispenser, and we will have our cal sensor. So once we have those three things selected, and I will get into this, sensor height and approach height a bit later, but we have those three things selected. So now what we want to do is, the first thing we want to do to make sure that you've set up everything correctly is that we want to make sure that you're able to go to your plane. So if I were to say here in the features, and if I have my cal plane there, I will want to set the rotation of the TCP so that the X, Y, and Z of the TCP line up with the X, Y, and Z of the plane. And I've done videos about that and how to do that. So what you need to be able to do is you need to be able to click move here. And so if you can click move here and you appropriately go to that origin, that is what we will be essentially replicating with our TCP cal, and what will be drastically easier. Okay, so now going back here to our TCP cal, the first thing we need to do is we need to measure the offsets. Assuming that this is a well-calibrated TCP and a well-defined plane, we want to measure what those offsets are to the sensor, because that's what we will essentially use to replicate our calibration. So now I can say here, measure offsets. And so I will click measure offsets. It will prompt me to move, in this case, it's safe to start there, but it will prompt me to go to the safe position. I will say continue. And what it will do is it will search in the Z direction, right, to see what that offset is to our actual plane. Once it feels that, it's going to search in the X direction, and it will sense that, and finally in the Y, and it will sense that. And so now it has measured the offsets. So now that I have measured the offsets, I want to say calibrate TCP. So I'm going to say calibrate TCP, move again back to our safe position, and I can hit continue. And so now this is going to calibrate our TCP and allow us to grab those offsets, and it will generate a TCP that you are now able to grab in the installation node. So it's a TCP that is provided by the UR cap. And you can see at the end, it will go to that point, and you want to make sure that that point is accurate. So so I can move up here using, I'm using the joystick here in the background, but I've moved up. And so now if I go to my installation under WireTank TCP cal, I have a new WireTank TCP. And in my program now, I can go in here into the toolpath, and when I goes to use the toolpath here in the toolpath move, I will set that as my TCP. So I will say it's a fixed TCP, and I will use the WireTank, calibrated TCP. And so now what I can do, for example, is I can change from this tip here, right, to this drastically different tip here. So you can see like the offset that those have. And so when I put this tip in here now, and I go back into my installation, and I say TCP cal, I'm going to recalibrate this TCP. It will ask me to move to that new position. I will hit continue. And again, it will go in there, it will search for the offsets. And once it has searched for the offsets, it will line up there. And now I can go to my program, and because I'm using the calibrated TCP, I can hit play on that. And you will see that it's going to approach, right, that same toolpath, and it will follow it exactly right per that, sort of calibrated TCP. And so that is a huge time saver, because you're able to deal with changes in tips, and even use completely different tips. And I can even use something like this, which is a sort of this completely bent. Let me put it maybe in an orientation that is easier to see in the camera. So you can see there how this is a bent tip, and I can say in the installation here, go back to the installation, again calibrate TCP. It's going to prompt me to move so that I can make sure it's a safe path. I hit continue, and so now again it's searching in that C direction. Once it feels the resistance of the surface, it notes the length, so now it adjusts for this offset, then this other offset, again centers on that tip, and now I can hit play again, and now this is going to be actually running with this bent TCP, and it will follow the path accurately even on this bent TCP. So you can see it there as it's finishing its path. So again, the only thing we needed was a calibrated TCP, a calibrated plane, and a sensor I/O.